Okay, let me share my screen. So today we're gonna get into coding. Let me see, Windows, entire screen. Okay. So a quick recap for the last session. So last session I introduced you to Rust, and basically we went through like how to install, trying to install in Mac and Linux. This was the instructions and how to run a project. So after setting up, this is how you create a project, and how you run a project is cargo run. And we learn about the basics of programming, like how to write a hello world program in Rust, how to create a variable. We also spoke about mutable in Rust. Variable are non-mutable, so you have to make it mutable. You have to start with a keyword, the mute keyword, and yeah. So went through the basics, and I think you went through it over the weekend. We also spoke about different scalar types: character, integer, and all that. So today we're going to get a bit deeper, and we're gonna get our hands dirty into function, learning about function, control flow, and decision making. Does anybody has any question based on what we did last week before we can proceed? And show of hands, who managed to install Rust? Because we're gonna need it like from tomorrow. We're gonna have to. Okay. And Regina, did you manage to install Rust?
No, actually, I wanted to tell you, when you sent the link to the Telegram on Tuesday, I tried to join the group, but unfortunately I didn't. I wanted to write an email so that you can resend it, and I just said let me wait for the class.
Okay.
So I didn't get things we were supposed to, but I don't have Rust.
Okay, so I think we should have, for people who haven't installed, we should have maybe a session maybe on Wednesday. I don't know. If you want that, because if you're installing on Windows, it's more tricky to install it on Windows than it is to install on Ubuntu, Linux, or Mac. Which computer are you using? Are you using Microsoft or Mac?
Microsoft Windows.
Okay, so it's a bit tricky with Windows, so I'm gonna have to show you how to do that.
I think I'm okay with doing that on Wednesday, if you're okay.
But for now, you can use the Rust Playground. I'm gonna show you how the Rust Playground. So the Rust Playground is basically you can try to run Rust programs online. The only thing you can't do with it is you cannot do file, like for example, writing in a file, write a program that use file handling. Let me show you now. This one here. Yeah, so this is the playground that you can use to play around with Rust. So even today, just go to playrust/lang.org to play around with it, because you're going to be coding along together today. Okay, so today, flow control, functions, and decision making. So what is a function? So a function For those who have background in coding, it's not new. Function is like a recipe you can use over and over again instead of writing the same steps repeatedly. So this makes your code cleaner, and it also avoids your code from being redundant, because you use one program, you use one function over and over again. A function in Rust has the following syntax. So you have the function name here. So remember, you have to start with fn, and then there's a function name, and here is the perimeter. So you write the perimeter name and the type of the perimeter. Remember, we spoke about types. There's integers, there's i32, i64 for integers, and then there's unsigned integers like u32, u64. So unsigned integers don't have negative. So, and then there's also floating point like f32, f64. So these are the types, and then there's a return type. The return type. So here you have to put the type that you want to be returned. So if you want to return a floating point, then you say f64. If you want to return an i32, then it's i32. And inside here, inside the bracket, the parentheses, this is the function body. So here is where you write whatever you want your function to do, and then at the end there's return value. But the difference between Rust and other programming language, here you don't have to specify, you don't even have to write return and whatever value that you want. You can just write the final return value just like that, and you don't put a semicolon. So when you don't put a semicolon at the end, that will specify that this is the value that you're going to be returning. And it has to go hand in hand with the return type. You can't put a string here on a return value, and here on return type, you put a floating point. It has to be consistent. So this is the basic syntax. If it doesn't make sense now, don't worry, because we're going to see it in action for it to make sense. So here, just the explanation. The fn keyword just declares the function, and the function name uses a snake case. So this is snake case. The name, no capital letter, underscore, and the name, whatever you want it to be. And then there's a parameter, just like I explained. And so you have to follow this syntax. But then there's different type of functions. And it will make sense if you have coding background. So there's functions, simple functions that have no return. Okay, somebody's joining us. There's simple functions that have no return. So this is an example. Let me just play around with that. Oh, okay, let me hide this. So we have a function that has no return. For example, we created a function called function greet, and then it only returns print hello world. So let me show you let me show you in action. So we have a function greet, and then remember you have to follow the syntax. So here you see the syntax, and then here we can put the syntax type. But here we only dealing with a function that does not have a return value. So we're just gonna leave it empty, and then we're gonna print hello world. So this is a function with no with no return. we're gonna see in action very soon. So, and then there's another one that we also have to deal with. There's a function with perimeters. So here I'm very used to dealing with I'm a Java person, so I kind of like get it mixed up sometimes. So there's also a function that has a perimeter and a return. So this is the one that I showed you. So let's say function square, and then we have num, we have I32. Remember, we have to specify the type of parameter that we're using. That's going to be the type of the parameter, and also the return type. Here the return type. Here the return type is also another I32. And return type is I32. And here we just square the number that we enter in the parameter. And remember, we don't put semicolon because we're returning, remember. So semicolon for return, for return, no semicolon for return. And then there's also another one with multiple parameter. So we say function add, and here we're adding I32, and then we're also adding this function. So it's going to be, these two functions are going to be, and we're going to return an integer, a signed integer, and we're returning the addition of these two numbers. So now let's see it in action. So we're going to create a main. And we just so now when you create a function, you can also call the function. So let's say you want to call greet. It's as easy as, so here we call the greet function. Where did that go wrong here? Oh, square is never used. It's because I never use this. Because remember, with Rust, they don't give you room for errors. So me not using these functions here is already displaying errors. Like here, it's saying that you're not using square, you're not using add, and so on and so forth. But let's just ignore it for now. But you can see here, if I call the function greet, it called the top function, and then it just print out hello world. So let's now call the other function. Let's call add. So we're going to, no, let's call square. So now we're calling the square function. And we putting, remember, this is the parameter. So the parameter has to be a number. So let's say it's 8. What do you think is going to print out? What do you think is going to print out if I just write it like this? I put a square and then 8. Does anybody has an answer? Anybody? Or you can type it. Just guess. This is a function. The function says, okay, we're taking a parameter, an I32, and I32. There's something wrong about this code. There's something wrong here. The function is okay. The function is correct. So I'll put a I32. Yes, and then I just call it like that. So let's run it. Oh, after a semicolon. So here, there's an error. There's an error because I did not print it out the proper way. Here, the first function, I'm printing it out. So this is straightforward. It's just, this function just prints out this value. But here, I just multiplied these values, but I didn't do anything about it. I did not print it. Does it make sense? Without a semicolon, the main is return the value from square, but there's no value. Yeah. So here the problem is, wait. I did not print anything here. So it's not going to work. So what I should have done is I should have print and then remember with Rust, the way you print it is you print it this way. You have to put your curly bracket. And yeah, this one is going to work. But you have to put your number here, your parameter. Don't forget, you put your parameter. So now everything is sorted. You can see now it is 64. And you do the same with add. You just copy and paste. So, but with add, we have two parameters. So since you have two parameters, we write these two parameters like this. We separate them with a comma. So we have like 5 and 6, for example. So these are two different parameters. And it's just going to add these two numbers. And it's going to print it out. So now you can see there's no errors because I used all my functions. So you can also try it out. I don't know if you have two screens. If you have two screens, you can also try to play with that and see how it works. Or I'm just gonna give you some time later on for you to code something. There's going to be some class work to do. Let me see how much time we have. Your time is moving so fast. Time is really moving so fast. So we use a function with a parameter. So we use that one, multiple parameter. And there's also a function with explicit return, where you explicitly write what you want to be returned. Like, for example, you want to return 100 or you want to return 200. So this one is explicit. Doesn't matter which parameter you put here. I can put here in 1,000. I can put here 10. I can put here whatever, but it's going to explicitly return the 100 divided by whatever I put here. So this one is explicit. And here, like I showed you how to call a function. Like The first one was grit, and the second one was squared. So you can even write you can also write a variable and then use your function. And this is going to return 25. So your variable is going to be 25. Here, your sum, your variable is going to be the addition of 3 and 4 according to the function that you created. So you can also do that. And one thing you have to note, parameters are immutable by default. So same thing, use mute for mutability. And in terms of ownership and borrowing, you use references such as the end str and the end and I38, for example, to avoid taking ownership. And then the last expression without semicolon is returned, like I showed you. So use return for early exit or the last expression with no semicolon. So the function are private by default. So use pub, for example, which we're going to be using later, a public function for public access. But we're going to be working with that later. So no semicolon on the last line means return this value. And quick practice, I want you to, okay, is everyone using the Rust playground? The Rust playground? Yeah. So I want you to create, I want us to practice, quick practice, create a function that calculate the tip. So I'm just going to show you the top of the function. So can you see the bottom? So I want you to calculate the tip. So it takes the bill and the percentage. So the bill can be, let's say the bill is 1,000 and the percentage is 10. So this function should calculate the 10% of the total bill. And it must return 100 because we're talking 10%. So if it's 15, it must return 150. Does it make sense? So create a function that does that. You can use the playground, or if you have installed Rust, you can use your editor. So let me show you the playground. So for those who don't know, let me type the link to the playground. So I'll send the link to the playground. So create an application, a function that calculates the tip of the total bill. So there's two parameters. There's a parameter for bill and then there's parameter for percentage. So yes, probably if you have this, you probably have this. This is like 75% of the work that's already done. I'm gonna give you 3 minutes to do it. Is everybody winning? Yeah. Oh, I'm hiding it. Let me put it here. Okay, let's get into it. Let's get into it. Okay, so this is what we had. So we had calculate tip. Then we have the bill parameter, which is a floating point. And then we have percentage parameter, which is also another floating point. But here we have to return a floating point because we're dealing with it's a percentage of a figure. So we need a floating point as well. So a floating point is just a number with a comma, like 10,5, whatever figure it is. So now to create the bill, it's just gonna be simple mathematics. So the bill is, we'll multiply the bill by the percentage, and then we divide it by 100. But remember, here we're dealing with floating point, so you have to make sure you put a point 0. Because if you leave it like that, then Rust will think that you're dealing with an integer and it's going to give you an error. So you have to keep that in mind. So simple as that. But now that we have our function, we want to run it. So we have to create a main function to run our program, because this function itself won't do anything. So we're gonna say let bill equal 1.5, bill equal 1.5. And remember, we're dealing with floating points, so you have to put a 0. And let the tip equal. So now we're going to use our function calculate tip, and remember the first parameter is going to be the bill itself. So we write bill because we already created a variable of bill. So it's going to be this, and then the second parameter is going to be the percentage that we want to use. So let's say we want to use 15%, then we put 15%. But then remember, our parameter is a floating point, so you have to put 15.0, and then this print. So now we'll print out our figure. So the tip on, we're gonna use our bill. So, and let's say it's gonna be ren. So we're using our bill, and then this is where we're going to put our value. So our bill value is gonna go here, and then we're going to have another value, which is the second value is going to be the tip. So the first parenthesis will be for the bill, and then the second parenthesis will be for the tip. So now, question for you, for those who did this, what's the first? What should I put here? Should I? Now this is a very simple question. Let me not ask you guys. So here I put a bill and then I put tip. And remember, I have to remember my semicolon. So this just essentially going to print out the tip on the bill, which is 1.5, and the tip, which will be no, I forgot something. I forgot to initiate the variable. So let tip equal calculate tip. So it's just going to print out the bill and then the tip. You have to remember my semicolon. And let's see, make sure. Okay, it looks all right. Let's run it. So you can see it prints out the tip on 1.5 is 225. But we can also try to make a few changes. Like, let's say we want to see we want to print out a floating point number, a number with commas, maybe with 2 commas or whatever. Then in this parenthesis, we do this, put the colon, and then you put a point, and if you want to round it to 2 numbers, you put a 2 here. If you want to round it to 4 numbers, you put it here. So in the event that, let's say I change the tip to 15.5%, if I leave it like that, if I don't specify, now it actually works, eh? It actually does the thing. But for best practice, you can specify how many commas that you want your value to display here. I don't know if it makes sense. Does it make sense so far? Okay. So for those who have experience in coding, I'm pretty sure this is not very difficult. But for those who are beginners, the best way to learn will be to just go through this documentation and try different values. So you write all this and then you try different values. So this is the step 1. You try different values, you see, you guess what is going to print out, and then once it prints, you try again for other values, and after practicing that way, then this next step will be writing this code without even looking. So just rewriting everything that is here without looking at the code itself. So that will cement it's going to cement that knowledge in your mind. Time is really running. I don't even know we're gonna finish this session. So another thing that you also have to know in Rust is the if and else, making decision. So decision making in Rust with if and else lets your program choose between different paths depending on whether a condition is true or false. So you give Rust a test like, is this number bigger than 10? So if it's bigger than 10, do this. Or if it's not bigger than 10, do something else. So this makes your program smarter because it can react differently based on the situation instead of doing the same thing. So this is an example of if and else. So let's say you created a variable called balance and it's 100. So now in the if and else, you can write like, okay, if the balance is greater than 50, if the balance is greater than 50, do this. Print you have enough number. Else, print low balance warning. So this is just a simple if else, and it can be anything that you want to create. For example, you want to create an app that let me just make something that you okay, like for example, let's say you are creating the WhatsApp app. So WhatsApp, many applications use if and else. So if I'm writing a message to, let's say I'm writing a message to Rudolph, the message won't, and I use the app, and then I select Rudolph, and then I type something to Rudolph, and then I send. It's not going to send that message to Regina, right? It's going to send a message to Rudolph. And why is that happening? It's because behind the scene, there's if and else. If I'm writing this message to this specific person, the message has to go to that person. Or else, if the message is sent to the other person, go to that person. So this is an example of how it works in programming. So if and else are just used to, depending on which condition, depending on the condition that you have specified. If this is bigger than that, do that. If the weather is 50 degrees, do that. If the speed of the car is running at 120 kilometers per hour, do that. Does it make sense so far? I think I'm not sharing my screen, eh? I'm not sharing the right screen. Sorry, guys. I was not sharing the right screen. Okay, so this is what we're talking about. So this is a basic if. So let balance is equal to 100. If the balance is greater than 50, you print this. Else, you do that. Okay, it makes sense. There's also multiple conditions that you can use. Like, okay, we have a balance. You're checking a balance, and this is you create a function. It's a parameter. So in this parameter, it can be any number that you put on your in your function. Let's say you put 5,000, or you can put 10,000. It depends on what you put in the parameter. But let's say now that thing that you put in the parameter is 1,000. So if it's greater than 1,000, print premium content. If the balance is greater than 100, this is what you print. If the balance is greater than 0, this is what you print. Let's see it in action. So for it to make sense to you. So let's remove this. No. Okay. So a simple way of doing it is, so let y equal 20, so 20.0. And so if y is greater than 10.0, print let's say less than 0, print. This is just a random program. The number is lower than 10. Else, if y is less than 20.0, so we're gonna print the number is less than 20. It's less than 20. And then else, so if it's not the case, then print whatever is not the case. Whatever is not the case. So now you have a number is 20. So we want to test it out. So if this y is less than 10, this is what's going to be printed out. Or else if the number is less than that, this is what's going to print out. Or else this is what's going to print out. So question to you, what's going to be printed out if I run this? If I run this, what's going to be printed?
You are not sharing the screen, Ben.
Oh, we can't see the code.
Okay, let me hide it. Why is this happening? I thought I was sharing the whole screen. Sorry about that. I thought I was sharing the entire screen. Okay, so I have this. So let's y equal 20. Okay. So if y is less than 10.0, so this is floating point, print this. Or else if y is less than 20.0, print this. Or else print that. So my question is, what do you think is going to be printed out if I run the program? Is it going to be, let's say this one is A, B, or C? Okay. Any other answers? Any? Just try, guys. Just try. I'd love everybody to just type out the answer. Even wrong answers. If you have a wrong answer, just type it out. Come on, guys. Wrong answers, wrong answers. Okay, so let's look at the logic. Here we have 20.0, so it's quite simple. Is it less than 10? Of course, it's not less than 10. Y is greater than 10, so this one is off. You can write this one off. And then we go to the second case. Is y less than 20.0? But if you're talking about 20.0, it means that that number has to be 19 point something. And of course, the y is not 19 point something, so we can also write this one off. So now we know that, okay, since it's neither of these values, then we know for sure that it's going to print out the last one. Does it make sense? Thank you for your answers, Rudolph. Wait, there's something that oh, sorry guys. In Rust, you don't do this. I'm kind of confused Java and Rust sometimes. So as we specified here, it's not the case. So does it make sense? Okay, this was a very simple if and else. So, okay, you see here, there's an example of how to work it. And I think, what time is it now? Another thing that you can use in Rust that is different from other programming language is what we call pattern matching. It's sort of like case when using cases. If you have coded in Java before, it's kind of similar to that. It's a powerful way to check a value against different possible shapes or cases, and then run the code that matches. So instead of writing lots of if, else, we can use match to clearly list out every possibility. For example, a number can be checked to see if 1, 2, or something else, if it's 1 or if it's 2, if it's something else. And Rust will guide you to handle all cases so your program is safer, easier to read. So this is an example of how you use matches. So here in this case, you are using char and you want to see if this parameter, so whatever parameter you put, whatever character parameter that you put in this function, if it matches with an A, then you print out excellent. Or if it matches with a B, then you print out good job. And if it matches with a C, you print average, and so on and so forth. And at the end, this means anything else. So you can see here there's A, B, C, D, F, and here there's an underscore. So underscore just basically mean anything else. So if it's not A, B, C, D, F, then invalid grade. And this is another example on how you can use match. If traffic light, you have your traffic light, and here you're going to return a static string. And remember here also you can see there's like a end here. This just tells Rust that the static means that you're not going to, as long as the program is running, you're not going to lose the value of the string. The string is going to be valid as long as you run the program itself. So here, with numbers, if you light, whatever you put in your parameter can be, let's say you put 1, because you're dealing with I32, 1, 2, or 3. If it's 1, then return red stop. And take a closer look here. You see here we're returning a string. So this is what's going to be returned. Red stop is a string. Yellow caution is also a string. So if it's 1, then it returns this string. If it's 2, then it returns this. And if it's 3, this is what it returns. And so on and so forth. And this is anything else. And here's the example of on how to use it. Here you are declaring the function traffic light 3, traffic light 5. So Let's see it in action. We can even do it together. The time is running because there was a section I wanted us to do together, but it looks like we won't have time to do it today. So what I'm gonna do is I'm gonna give you this this thing that we did today, and just go through it. And tomorrow we'll do an exercise together. Okay, another thing to mention is loops. Coders know about loop, and it works similar with like every other languages. There's a for loop, there's a while loop. While loop keeps running until there's a certain condition is met. So for example, we say like while count is less or equal to 5. So here we created a variable, a mutable variable that is 1. And then while count is less than 5, here we know it's already 1. This is what should happen. Do this. So basically telling the program, do this while count is less than 5. So if you enter this body of the while loop, initially the count is equal to 1. Then we can print out count. So you print out count, which is the 1 itself. And then when we go under this loop, we're just saying count plus 1. When you see something like that, count plus equal 1 is the same as count plus 1. So count plus 1 now becomes a 2, and then we come back to the loop again, and now count is equal to 2. Remember, we use a mutable variable, so we can change it. So now count is equal to 2. But then when you go to the while loop, is count still less than 2, less and equal to 2? Yes. So the loops keep running while count is less than 5, less or equal than 5. So it's going to be equal to 1, equal to 2, equal to 3, equal to 4. Keeps printing until it's going to be a 5. It's going to print out the 5, and then count is going to be count plus 1, which is equal to 6. But then count is going to be equal to 6, and it can no longer print anything, because that's when the loop is going to end. And we can print out once the loop has ran, then it goes to this statement, done counting. And there's also ranges. You can also loop, use the for. There's also a for loop where you can loop from a specific number to another number. Maybe you can say from 2 to 5, or from 1 to 5, or whatever it is. In this case, in this for loop, we are looping from 1 to 5. So this dot just simply says 1, whatever number, 1, 2, 3, 4, until it's equal to 5. So from 1 to 5, print out I. So now at the first iteration of the for loop is going to print out 1. At the second iteration is going to print out 2. At the third iteration is going to print out 3, and so on and so forth, until it's equal to 5. Then it's going to print out 5, and then it's going to stop. So this is another way of using it. So here you print out up to 4. When you do it this way, because there's I in 1 until 5, until I is equal to 5, and then there's also another one where it's 0 ... 5. So it's going to print out every number up until 5, but not including 5. So it's going to be 0, 1, 2, 3, 4. So if I put a 6 here instead of 5, then it's going to print out numbers up to 6, up to 5. because it's the number that is below 5, below 6. I mean, sorry. And there's also infinite loops, which can be also very dangerous when you're dealing with it, especially when we deal with blockchain. You don't want your program to keep on looping forever, because every loop is essentially is like a transaction that happens behind the scene in your program. So it's something that you have to keep in mind, and always have a loop that ends. Your loop has to end. Don't let your loop go infinitely. So here, this is an infinite loop, but it has a break. So we created a loop. Here, the loop is equal to 0. And in this part here, we are printing out 0 up to whatever. So it's just going to count. So 1, it's going to print at 1, count to 1, count to 2, count 3. So print out 1, and then it goes here. Is if counter is equal to 3, counter is not equal to 3. It continues 2. If counter is equal to 3, it's not equal to 3 until it reaches 3, and then it goes in here. If counter is equal to 3, then you break. I suggest you try this and you use different numbers to see how it works. And tomorrow we're gonna deal with errors, and there's a class work we're gonna do together. So what I'm gonna do tonight, I'm going to give you this. I'm just gonna edit it a little bit, remove some stuff, and send it to you, so that tomorrow we'll just code together, straight out. We just code together a program that uses everything that we learned today. So that program is going to use if and else. We're going to use a loop. We're also going to use pattern matching and all this. So for now, when you get time, maybe tomorrow lunchtime, or maybe even now in the evening, just go through this and test it out. If you don't understand anything, you can drop me a text. And tomorrow we're going to be coding together. We're going to create a project. So let me just go down here. We're going to create a project where we create a text calculating program, where we're going to calculate taxes based on different tax brackets, and we're also going to calculate the gross salary of whatever salary we have. Like, so it's going to be the salary minus the tax, and we're also going to categorize salaries into entry level, mid level, senior level. Today, for beginners, it's probably a lot for you to take in, so I understand. But just go through it slowly. Tomorrow we're going to work together, and it's going to make sense. I'm gonna end now, but before we go, if anybody has a question, can ask. Any questions or any concerns? All right, so I'm going to send you this file. I'm gonna upload it, so give me like 10 minutes, and please go through it, even if you can go through it tonight, because tomorrow we're going to be coding together. We're going to be helping each other to create a simple application that uses everything that we learned. Okay, so that's it for tonight. Let me end the recording. And good night. See you tomorrow, same place, same time.